Hi all. I'm continuing with question number 21 from exercise 5D. So it says you need to prove that sec 8a minus 1 upon sec 4a minus 1 is equal to tan 8a upon tan 2a. So the left hand side says sec 8a minus 1 upon sec 4a minus 1. Okay. Conversion of sec into cos 1 upon cos 8a minus 1. Now this particular line, I'm just putting a division sign over here, and sec 4a is equal to 1 upon cos 4a minus 1. Now take LCM over here, 1 minus cos 8a upon cos 8a divided by 1 minus cos 4a upon cos 4a. So this is equal to 1 minus cos 8a upon cos 8a divided by 1 minus cos 4a upon cos 4a. Okay, see, I've taken the LCM, right? So this can be written as 1 minus cos 8a upon cos 8a into cos 4a upon 1 minus cos 4a. Now 1 minus cos 2 theta is 2 sin square theta. So this formula I'll apply here as well as here. So 1 minus cos 8a will be 2 sin square 4a upon cos 8a into cos 4a upon 2 sin square half of 4a is 2a. Okay, next step. Now this sin square and this sin square, I'll write it as sine into sine. So the sine square 4a, I'll take it twice. Okay. So the next step, 2 sine 4a into sine 4a upon cos 8a into cos 4a, 2 sine 2a, sine 2a. Okay. Now see, what I will do is I'll apply half angle formula over here for sine 2a. Okay. And I'll group these terms, 2 sine 4a cos 2a, cos 4a. This I will group. The green colored terms I will group. Fine. So see, sine 4a. See, sine 2 theta is equal to 2 sine theta cos theta, right? So this will be 2 sine 2a into cos 2a. Now the green color terms, this terms, I'll take it together. I'll write it as 2 sine 4a cos 4a. Okay. And then down it will be cos 8a into 2 sine 2a into sine 2a. Okay. Now there are some cancellations over here. 2 sine 2a, 2 sine 2a is getting cancelled, right? Okay. Now observe this term over here, the one marked in red. Okay. Now here I'll apply half angle formula in the reverse way. So 2 sine 4a cos 4a. So 2 sine 4a cos 4a can be written as sine, from right to left, it is double angle. So the double of 4a is 8a. So this is sine 8a. Okay. The red colored terms over here. So cos to A, I'll type the next step on the new page. This is equal to cos to A into sin 8A upon cos 8A into sin 2A. Now sin 8A upon cos 8A is tan 8A, okay, and cos 2A upon sin 2A is equal to cot 2A. Take cot in the denominator, so this will be tan 8A. Send this in the denominator, so that will be tan 2A because cot and tan are reciprocals of each other. So this is equal to your RHS. Fine. Let us go to the next problem. Question number 22. Fine. Question number 22 says left hand side is tan 2A minus sec A into sin A. Fine. So sin 2A upon cos 2A is tan 2A. Take this sec A down, okay, in the denominator. So it will be cos A. Sec and cos are reciprocals of each other. Fine. Take LCM. Sin 2A cos A minus cos 2A sin A upon cos 2A cos A. Okay. So this is sin A cos B minus cos A sin B, compound angle formula. So sin A cos B minus cos A sin B is sin A minus B. So this is 2A minus A upon cos 2A into cos A, right? So this will be sin A, 2A minus A is A. See, this is sin A minus B, okay? So A is 2A and B is A. So A minus B, 2A minus A is A upon cos 2A cos A. Now sin A upon cos A is equal to tan A upon cos 2A. Send a cos term up, it will be sec 2A into tan A, which is equal to your RHS. You can take a look at the RHS. Fine. Let us go to question number 23, sub question 1. Left hand side is equal to cos A plus cos B the whole square plus sin A plus sin B the whole square. Okay. On the right hand side is 4 cos square A minus B by 2, as you can see in the problem. Keep the textbook open in front of you. Okay. Fine. So first bracket, just open it. Cos square A plus cos square B plus 2 cos A cos B. Open the second bracket. Sin square A plus sin square B, 2 sin A sin B. So cos square A plus sin square A is 1. Cos square B plus sin square B is 1. Now from these two terms, take 2 common. So it will be cos A cos B plus sin A sin B. Now this is compound angle formula. Once again, cos A cos B minus plus sin A sin B is cos A minus B. Okay. Now from these two terms, take 2 common. So 2, 1 plus cos A minus B. Now let A minus B is equal to theta. So 2 into 1 plus cos theta, right? Now we have this formula. 1 plus cos 2 theta is equal to 2 cos square theta. So 1 plus cos theta will be 2 cos square, half of theta is theta by 2. So this will be 4 cos square. We have taken theta as A minus B. So replace it with A minus B. Theta is A minus B, and this is equal to your RHS. You can try question number 23, sub question 2 for self study. Okay, similar it is. I'm taking up question number 25 right now. We need to prove cos alpha into cos 60 minus alpha into cos 60 plus alpha. Okay, is equal to 1 upon 4 cos 3 alpha. This is what we need to prove. Now see, there are two terms over here, cos 60 minus alpha and cos 60 plus alpha. Okay, so multiple ways to solve this, right? So first I'm going to simplify cos 60 minus alpha. So this is cos A minus B, which is cos A cos B plus sin A sin B. So half into cos alpha plus root 3 by 2 into sin alpha. Okay, which is equal to cos alpha plus root 3 sin alpha by 2. Similarly, one second, I'll just rewrite this. So this is equal to cos alpha plus root 3 sin alpha by 2. Similarly, if you expand this term, 60 plus alpha, this will be cos alpha minus root 3 sin alpha by 2. Use a compound angle formula to expand the second term as well. This is term 1 and this is term 2. Both the places I am taking compound angle formula. Now we'll multiply these two terms. Okay, so cos 60 minus alpha into cos 60 plus alpha is equal to cos alpha plus root 3 sin alpha upon 2 and cos alpha minus root 3 sin alpha upon 2. Okay, now on the top in the numerator I'm going to do a plus b into a minus b, which is a square minus b square upon 4. Okay, so this is equal to cos square alpha minus 3 sin square alpha upon 4. Now sin square alpha I'm going to write 1 minus cos square alpha as per fundamental identity. The reason being, right hand side of the problem has a cos term. So we'll convert everything into cos. Okay, upon 4. Now I'm going to multiply 3 with the entire bracket. So this is equal to cos square alpha minus 3 plus. Okay, this minus into this minus is plus 3 cos square alpha. Okay, upon 4. So this is equal to 4 cos square alpha minus 3 by 4. Okay, so this is the product of these two terms in the LHS. Now what I will do is I'll start with the LHS. LHS is equal to cos alpha into. Now look at these two terms. We have calculated individually and we have multiplied these two terms. And the answer was 4 cos square alpha minus 3 upon 4. Okay. 4 cos square alpha minus 3 upon 4. Multiply cos alpha within the bracket. So it will be 4 cos cube alpha minus 3 cos alpha upon 4. Okay. And this particular term is cos 3 alpha, triple angle formula, which is equal to your RHS. Fine. Let us go to question number 26. Question number 26. Okay. Left hand side is equal to cos alpha, cos cube alpha minus cos 3 alpha upon cos alpha. Okay. Fine. Plus sine cube alpha plus sine 3 alpha upon sine alpha. The RHS is 3. So we are going to use triple angle formula here and here. So this will be cos cube alpha minus 4 cos cube alpha minus 3 cos alpha upon cos alpha plus sine cube alpha plus 3 sine alpha plus 4 sine cube alpha upon sine alpha. Okay, so this will be cos cube alpha minus 4 cos cube alpha is minus 3 cos cube alpha. Okay, minus 3 cos cube alpha minus into minus is plus 3 cos alpha upon cos alpha plus cos cube alpha plus 4 cos cube alpha. Okay, it's minus, sorry. I have written the formula wrong. So sine cube alpha minus 4 sine cube alpha is minus 3 sine cube alpha. Okay, plus sine 3 alpha plus 3 sine alpha upon sine alpha. Right? So cos alpha minus 3 cos square alpha plus 3 upon cos alpha. So in the numerator, I have taken 3 common. Oh, sorry, cos alpha common, which is getting cancelled. Here I am taking sine alpha common. So this will be minus 3 sine square alpha plus 3. So sine alpha will get cancelled over here. Okay. Now this will be 3 plus 3 will give you 6. Okay. So this is 6. And the remaining terms are minus 3 cos square alpha minus 3 sine square alpha. So I'll write 6 minus 3 cos square alpha minus 3 sine square alpha. 6 minus 3, take minus 3 common, cos square alpha plus sine square alpha. Now cos square alpha plus sine square alpha is 1. 6 minus 3 is equal to 3, which is equal to your RHS. Okay. That was your question number 26. Fine. Let us go to question number 27. So question number 27 says left hand side is equal to cos square 2 theta minus sine square theta. Right hand side says cos theta into cos 3 theta. Okay. Now cos square 2 theta minus sine square theta. Okay. Now this can be written as cos 2 theta the whole square minus, here I'm going to apply fundamental identity, 1 minus cos square theta. Now cos 2 theta is 2 cos square theta minus 1. There are 4 formulae for cos 2 theta. But then why am I using this formula is because right hand side has all cos terms. Okay. And I'll open the bracket over here. Apply a minus b the whole square. So 4 cos raised to 4 theta minus 4 cos square theta plus 1 minus 1 plus cos square theta. So plus 1 and minus 1 is getting cancelled. Okay. Right. So minus 4 plus 1 is minus 3. So this will be 4 cos raised to 4 theta minus 3 cos square theta. Take cos theta common, which will give you 4 cos cube theta minus 3 cos theta. So this is equal to cos 3 theta, which in turn is equal to your RHS. Fine. Okay, let us go to question number 28. Question number 28. Yeah, left hand side is 1 plus cos 2 theta upon cos 6 theta upon cos 4 theta. Okay, somewhat like this. Okay, so now first I'm going to apply cos C plus D, cos C plus cos D formula. So cos C plus cos D is equal to 2 cos C plus D by 2 and cos C minus D by 2 upon cos 4 theta. So this is 1 plus 2 cos 4 theta, and this will be cos 2 theta minus 6 theta is minus 4 theta upon 2, which is cos minus 2 theta upon cos 4 theta. Now this is getting cancelled. Okay, cos 4 theta is getting cancelled, and cos minus 2 theta is cos 2 theta, right? So this will be 1 plus 2 cos 2 theta. Okay, now see, our RHS is sin 3 theta upon sin theta. Okay, this also you keep in mind. Now cos 2 theta, I'm writing it as 1 minus 2 sin square theta. Now cos 2 theta has 4 formulae, but then why I'm writing sine formula is because right hand side terms have sine. So this will be 1 plus 2 minus 2 sin square theta. So this will be 3 minus 2 sin square theta. Okay. So this is what we have simplified. The LHS is simplified till here. Okay. Let me just go back for a while to check whether the things are correct or wrong. So this should be 4. Sorry. 2 into 2. This should be 4. Yeah. Now take a look at the RHS. There is sin theta in the denominator. So this particular step, I'm going to divide by sin theta and I will multiply by sin theta because we require sin theta in the denominator. Okay. So after simplification, I divided by sin theta, I multiplied by sin theta. Now multiply sin theta within this bracket. So this will be 3 sin theta minus 4 sin cube theta upon sin theta. So that is sin 3 theta in the numerator. This is sin 3 theta upon sin theta, and that is equal to your RHS. I hope you understood this. Let us go to question number 30. Left hand side 1 upon sin 10 minus root 3 upon cos 10. Okay. So this equal to cos 10 minus root 3 sin 10 upon sin 10 into cos 10. I took LCM, right? Now look at this particular format. Sin 10 cos 10. I'll multiply this with 2 and hence I have to divide also with 2. 2 sin 10 cos 10. So multiplying with 2 and dividing with 2. Now purpose of multiplying the denominator with 2 was I can apply 2 sin A cos A formula. Okay, 2 sin A cos A is equal to sin 2A is equal to sin 2A. So see this 2 sin A cos A is sin 2A. So 2 sin 10 cos 10 Okay, will be sine 2 into 10, which is sine 20. Okay, fine. The double of 10 is 20. Double of a is 2a, right? But then the double of 10 will be 20. So that's the reason why I multiplied and divided with 2. Okay, now see, this is 2 cos 10 minus root 3 sine 10. Okay, down it is sine 20. Okay, now next step is very crucial. So again multiply and divide by 2 in the numerator. Purpose I will tell you. Denominator is sorted. It is sine 20. But then here I am multiplying and dividing with 2. Now this 2 into 2 I'll make it 4 and I'll send this half within the bracket. So half sine 10 minus root 3 by 2, half cos 10, this is cos 10, sorry, minus root 3 by 2 cos 10. Okay, so I'll just multiply this half. This half I'll multiply within the bracket. So this will give me 4 half into cos 10 minus root 3 by 2 sine 10 upon sine 20. Okay, so 4, this half I'm writing it as cos 60 and this is cos 10 root 3 by 2, it is sine 60 sine 10. Okay, upon sine 20. So this is cos A cos B minus sin A sin B. So cos A cos B minus sin A sin B is cos A minus B. So this can be written as 4 cos A minus B, 60 minus 10 upon sin 20. So 4 cos 50 upon sin 20. Okay, I've just written this values now. The RHS is 4. Okay, but then this cos A cos B minus sin A sin B is cos A plus B. So this is, sorry, I used the wrong formula. This is cos A plus B. Okay, so this will be cos 70. So 4 cos theta is equal to sin 90 minus theta, complementary angle. So this I'll apply over here. Cos 70 is equal to sin 90 minus 70 upon sin 20. Okay, and cos sin 90 minus 20 is nothing but sin 20. Sin 20, sin 20 is getting cancelled. The answer is 4. Okay, so I will just revisit. First, I have taken LCM, multiply and divide with 2 so that I can apply half angle formula in the denominator. 2 sin A cos A is sin 2A. So 2 sin 10 cos 10 is sin 20. Okay, now here next step was very crucial, multiply and divide by 2 itself in the numerator and then take that half inside the box bracket, which I have done. Fine. So half and root 3 by 2. So half is written as cos 60, root 3 by 2 is written as sin 60. Why we do this? Because we can apply this cos A cos B minus sin A sin B formula, which is cos A plus B. And towards the end, for cos, I've taken complementary angle. Cos theta is sin 90 minus theta. So we get sin 20 in the numerator as well. 90 minus 70 is sin 20. And denominator already has a sin 20. Okay. So that is how the problem is completed. Okay. Thank you.